Have you ever think of what a pure water could look like? I mean a very pure one. No matter how pure a water could be, it's going to have ions. But these ions are not impurities. Instead, they are products of water itself. They come from water. These ions are hydroxyl ion and hydronium ion. How is this formed? We know that when water splits, it can give us hydrogen ion plus hydroxyl ion. But this hydrogen ion is not always just free. Instead, the lone pair of electron of one of the oxygens found in the water is going to bind to the proton. So let's say we have these two water molecules. These two water molecules can automatically initiate their own ionization, and then this is going to take this proton. But before it take the proton, you need to know one thing. This water here is having two partial negative here and partial positive here, which means that more of the electron of the bonds that this oxygen and this hydrogen are sharing are towards the oxygen. So this is an electron, this is another electron. But then this is just an annotation. In real sense, it's just something like, let's say we have more of it towards this side and we have very few here. So when this bond is splitting, the electron is going to be with the oxygen, while this hydrogen is going to be electron deficient. So we are going to have this form an hydroxyl ion, and then this form an hydronium ion. So now that we have it this way, the positive charge of the hydronium ion is from this hydrogen, because the hydrogen is having a positive charge because it has lost electron. So we are going to have H3O plus. So I want you to keep in mind that all these are just annotation to explain what is happening. But to have a clearer view, let's look at the interactions between water themselves. Water have hydrogen bond holding them together. Let's say between this oxygen and this hydrogen of this water molecule, there is an hydrogen bond. Between this and this, there is an hydrogen bond. And same here, hydrogen bond. Now, let's say this water molecule gain a proton. Automatically, this water molecule is going to be having additional hydrogen to its two hydrogen. So that makes it H3O. And with a proton, H3O plus. So this plus. Now, this is having 3. To balance up, this bond here will cleave. And when this bond cleaves, this will hop to this oxygen. And when it does, this becomes a normal bond. Then this breaks and up, just like that. This breaks and this ups. Remember that this water molecule here was the first to get the proton, and now we have like 4 water molecules passing the proton to themselves, and this happens very quick, and it is adding to the conductivity of water. This concept is called proton hopping. Now we should ask ourselves this question: if water is splitting to give us hydrogen ion and hydroxyl ion, or hydronium ion and hydroxyl ion, what amount of hydroxyl ion will be formed? What amount of hydronium ion will be formed, or hydrogen ion will be formed? So this will lead to some mathematics here. When you have a reaction, let's say the reactant is A and B, to give the product C and D in a reversible reaction. There is a point where it reaches equilibrium. When it reaches equilibrium, the number of A and B that will be used up to form C and D will be equal to the number of A and B that will be gotten back from C and D. So at this point, there is no net reaction occurring. So the reaction is taking place, but as it is taking place, the reverse is also taking place, giving no net reaction. At a given temperature, the equilibrium constant for every reaction is the same and can be gotten experimentally. But mathematically, the equilibrium constant is also equal to the concentration of the products multiplied together over concentration of the reactant. Considering this reaction of water giving us H plus and OH minus, we could say that the KEQ for water is, what are the products? H plus, this means concentration, H plus OH minus over the concentration of water itself. To get the concentration of water, we need to know the mole and the volume, so in mole per liter. But we have some information here. The density of water is 1 kilogram per liter, which is equal to 1000 grams per liter. And we also know that the molecular mass of water, that is the mass of 1 mole of water, is 18.015 grams per mole. So that's the molar mass. Now, to get the concentration of water, all you have to do is divide this by this. So you say 1000 gram per liter over 18.015 gram per mole. So this is giving us 55.5. So we have this equals to 55.5. But what is the unit? Look here, we have gram here, we have gram here. Gram can cancel gram. We have per liter here and we have per mole here. But remember, this is a denominator which we can convert to 1 over liter, the numerator, divided by 1 over mole, which is same as saying 1 over liter multiplied by mole over 1, which is mole per liter, which is same as the molarity. So we have 55.5 mole per liter or molar. Now that we have this information, let's substitute for our equation here. We can now say KEQ is equal to proton concentration, hydroxyl ion concentration over the concentration of water, a pure water itself, which is 55.5 molarity. The value for KEQ can be gotten experimentally by measuring the conductivity of water. So at 25 degrees Celsius, when we measure this experimentally, what we have is 1.8 times 10 raised to power minus 16 molar. So we can also put this in our equation by saying 1.8 times 10 raised to power minus 16 molar is equal to the concentration of proton multiplied by that of hydroxide ion over 55.5 molar. Now let's cross multiply this. If we do that, we have 1.8 times 10 raised to power minus 16 molar multiplied by 55.5 molar, which is equal to the concentration of proton multiplied by that of hydroxyl ion. So when we multiply these two together, we call it ion product. Ion product. And this makes a lot of sense because this is an ion, this is also an ion, and we multiply both, which is product. So that is ion product, and it is denoted by Kw in the case of water. So all this is equal to Kw. Now let's multiply this. Let's see what we have. We have our 55.5 times 1.8. This is equals to 99.9, approximately 100. So when we say 100 times 10 raised to power minus 16, so since this is minus, for every 10 you multiply this by, this number here reduces. So this is 10 times 10. So this reduced twice, which makes it 1 times 10 raised to power minus 14. So when you have 1 times 10 raised to power minus 14, molar and molar, that makes it molar square, is equal to the proton concentration multiplied by the hydroxyl ion concentration, which is also equal to the ion product. Let me give you a quick reminder. Remember that when water splits, it gives H plus and OH minus. So if this water is pure, one thing is very sure, the number of H plus that we'll be having is the same as the number of OH minus that we are going to be having, because they all come from water. So when it dissociates, it gives H plus and H minus. So the number of H plus is equal to the number of H minus, and the concentration is also the same. So because the concentration is the same, we can say that the concentration of OH multiplied by concentration of H is same as concentration of OH square, which is also same as concentration of H square, right? So we can now rewrite this our equation that 1 times 10 raised to power minus 14 is equal to the concentration of OH minus square, which is also equal to H plus square. Now, if we want to look for concentration of H or OH, let's say concentration of H or concentration of OH, it will be equal to the square root of 1 times 10 raised to power minus 14. And this is straightforward, because for you to have 10 raised to power minus 14, all you have to say is 10 raised to power minus 7 times 10 raised to power minus 7. That is going to give you 10 raised to power minus 14. So the concentration of H plus is 10 raised to power minus 7 mole per dm cube of water, and this is also 10 raised to power minus 7 mole per dm cube of water. Dm cube is same as liter. Now this is telling us that for every 1 liter of water, you have 10 raised to power minus 7 mole of H plus and of OH minus. So practice this question, it would help a lot. Thanks for watching.